using a square wave which you can control the up or high time. In a PWM signal, the minimum and maximum voltage are the values that limit the wave's oscillation. The space between them is called amplitude. A cycle is the interval of the wave where you can find one full repetition. The time a cycle takes to finish is called period, and the frequency is 1 over period, which gives you how many cycles are in a time unit, usually a second. A very important concept in PWM is the duty cycle. The duty cycle represents how much of the period in which the signal is high. In our wave, the signal here is high, and here is low. To calculate the duty cycle, you need to know how much of the period the signal is high. Let us set our high time as 6 milliseconds, our downtime as 4 milliseconds, and our period as 10. Now, let's use a simple rule to calculate the percentage of the period in which the signal is high. 6 relates to 10 the same way as our variable in percentage relates to 100%. If you solve this, you'll see that you get 60%, meaning that the signal is high 60% of the time. Let's imagine a PWM signal that oscillates between 0 and 5 volts. Let's say this signal has a duty cycle of 50%. Something interesting will happen to the output voltage. Instead of being 5 volts as expected, it will now be 2.5 volts. Simply putting it, this is because in a PWM signal you multiply the max voltage by the duty cycle. This is the formula. By applying this to our situation, you will see we will reach the 2.5 volts. Let's see what happens to the different components of the wave when I increase the duty cycle. As you can see, when I increase the duty cycle, the output voltage also increases. And when I decrease the duty cycle, the output voltage also decreases. Keep in mind that the output voltage can only oscillate between the minimum and the maximum of the PWM signal. Now, let me show you this example in real life.